In this video, we are going to learn about subatomic particles and isotopes. Each one of the elements in the periodic table is made from atoms. Atoms are the basic unit of any element. One of the landmark discoveries within atom was the identification of 3 subatomic particles that are present in all atoms. These subatomic particles are listed in table 2.1. We can observe that these subatomic particles include electrons, which the common symbol for an electron is an E with a negative sign. Electrons have a -1 charge. When it comes to their mass, you can see that is 9.07 times 10 to the -28. And by now we know that electrons live outside the nucleus of an atom. Atoms also have protons, and protons have more common symbols, including a P with a plus sign, or an H plus. Protons have a charge of +1. Their mass is 1.67 times 10 to the -4 grams. And protons are found in the nucleus of an atom. Lastly, we have neutrons. Neutrons, their common symbol is an N, and at times you see that that N can have like a 0, which is called a naught. So N naught is another symbol for a neutron. Neutrons have a 0 charge. When it comes to their mass, they have the same mass as a proton, 1.67 times 10 to the -24 grams. And they also live inside of the nucleus of an atom. The information for protons, neutrons, and electrons has been incorporated at the periodic table. One of the things that is known is that when it comes to each one of the boxes in the periodic table, we can observe that there's information that it is given. We have the element symbol and the number that is right above, and it also can be illustrated in the corner of that box. It is known as the atomic number. And remember that when it comes to the periodic table, currently it is arranged in increasing atomic number. The atomic number is equal to the number of protons that are present in an atom. And currently, because we haven't talked about charged atoms, understand that the atomic number is also the number of electrons that are found in an atom. In the periodic table, we also have the atomic mass, which is a number that it is written below the element symbol. When that atomic mass is rounded to a whole number, that's what we know as mass number. And the mass number represents the addition of the number of protons and the number of neutrons that are present in a nucleus for an atom. All of that information, other than finding it on each of the boxes that we have for the elements in the periodic table, we have a specific symbol, which is called atomic symbol, which is the full representation of an element, which is going to communicate both the name of the element by illustrating its elemental symbol. Then it's also going to show you the atomic number, meaning the number of protons in that atom, and it's going to give you the mass number, which is the rounded atomic mass that illustrates the addition of protons and neutrons in an atom. So for example, if we have the element oxygen, and we know that oxygen has an atomic weight of 16.00 and its atomic number is 8, the atomic symbol for oxygen will be written in the following manner. We will write the symbol for the element, which is O. On the top left corner, we're going to write a 16, which is the mass number for oxygen. And in the bottom left corner, we're going to write an 8, which is the atomic number for that element. One of the important things that we must understand is that when it comes to these atoms, and they exist in nature, atoms have isotopes. In isotopes, specifically, is going to be atoms of the same atomic number, but different mass numbers. That means that is going to be atoms of the same elements, but they are different only by their number of neutrons. Most elements consisting of naturally occurring mixtures have two or more isotopes. For example, when we look at figure 2.12, we can see that silicon, which is a metalloid, has 23 known isotopes. In the table below, we have the known isotopes for the metal element magnesium. And we can see that when it comes to the atomic symbol for magnesium for each of the isotopes, we can observe that magnesium, all of these isotopes are going to have the same number of protons, meaning 12, because they all refer to magnesium. The only difference between magnesium 24, magnesium 25, and magnesium 26 is the number of neutrons that are present in those isotopes. Additionally, another piece of information that is illustrated in this table is the percent abundance. That means that when a sample is obtained and magnesium is mapped, the percent abundance is going to tell us specifically what is the type of magnesium isotope that is most commonly found. And when we look at these numbers, we can see that magnesium 24, because it has a high percent abundance, is the most common type of magnesium, followed by magnesium 26, and lastly, magnesium 25. Now, if there are multiple possible isotopes for the majority of the elements in the periodic table, how do we accurately but concisely communicate the mass of an atom? Well, when we look at the atomic mass, if I go to the slide before, meaning this number, that number is obtained by doing a specific calculation that is called the weighted average method. In the weighted average method, what we have is that the mass of the isotope and its percent abundance is actually utilized in order to calculate the atomic weight for that particular atom. Here we have the example of chlorine. When it comes to chlorine, there's actually two isotopes of chlorine that can be found: chlorine 35 and chlorine 37. We can also see in parentheses that this is the mass of chlorine 35, while this is the mass of chlorine 37. And additional information has been provided, which is the percent abundance for chlorine 35 and the percent abundance for chlorine 37. We can see that chlorine 35 is the most abundant out of the two isotopes. Now, how do we calculate the atomic weight for a particular element? What you do is that you take that percent abundance and you change it into a decimal number by dividing it by 100. Then you're going to multiply this value by the mass of the isotope. Then you will add that result to a similar calculation where we multiply the decimal number that came from the percent abundance times the mass of that second isotope. That's why it is called a weighted average method, because we are taking into account the percent abundance and the mass of the isotope and adding it sequentially to all the different isotopes and the information that we have, always by taking percent abundance and multiplying it by the mass of the isotope. And you can observe that when it comes to the periodic table, many periodic tables will show that the mass of chlorine is the following. And if you round the answer to 2 decimal places, this is what is illustrated. If I go back to a previous slide and I look at chlorine, I know that it is a little bit fainted, but you can see that that is 35.45. Which is the result that was obtained here. You can clearly see it in the periodic table that has been posted on Canvas.